Hello, my dear students. Welcome to the subject of statistics for the class 12th English medium, part 2, chapter 5, differentiation, presented to you by Vitan sir. Today we will be discussing the next topic, that is maximum and minimum values of the function. Any function, no matter what it is sure to have a value which is the maximum and then the value which is the minimum. That can be clarified more with the diagram I am showing you guys here. As you can see on the diagram, this A, C, E are all the maximum values of each and every trend, while B and D are the minimum values. All of these points which are at the very extreme are known as the stationary points. Stationary points means those points are at the extreme. At this particular point, it is neither increasing nor decreasing. It can be A, it can be B, C, D or E. Now A, C and E are the points with maximum values, while B and D are the points with minimum values. That means we can say that a single function can have more than one maximum value and more than one minimum values. Now let us understand these points in a maximum and minimum separately. We will start with the maximum points here. I will depict it using a diagram. We have the value a, then a plus h and a minus h. That means original is a, then somewhat more value is a plus h and the less value is a minus h. When we put all these three into functions, when we get a diagram like this, then we can say that fx is maximum at the point a, because this is the point, this is a stationary point where the value of function x is maximum. A plus h is less than a minus h is also less than a, that means a is the biggest value. If fa is greater than fa plus h and fa is also greater than f minus h, then fx is said to be maximum at x is equal to a. So this is the point where the function is maximum. Next, we will take the similar values, that is a plus h, a minus h, but here as you can see at the point a it is minimum. If fa is less than a plus h and fa is also less than fa minus h, then fx is said to be minimum at x is equal to a. So here you can see that at this point it has the minimum value. A plus h has a more value, a minus h also has a more value, but a has the minimum value here. So at this point the function will become minimum. So it will give you the least value possible. Now we have depicted it using a diagram, but how to calculate it using a statistical method? So the conditions for maximization and the minimization. First of all, we know that when f dash x is greater than 0, the function is increasing, and when f dash x is less than 0, function is decreasing. Now this is a concept which we studied in the previous tutorial, that was the increasing function and the decreasing function. So when f dash x is more than 0, it increases. When f dash x is less than 0, it decreases. So what if f dash x is equal to 0? When function is maximum or minimum, it is neither increasing nor decreasing. That is, it is stationary. That's what I was trying to say, that when it is either a maximum value or the minimum value, it is not increasing, it is not decreasing, it is stationary, it is stable. So whenever a value is not increasing and not decreasing, naturally it has to be equal to 0. So the necessary condition for maximization and minimization is that f dash x should be equal to 0. It is not increasing, so not more than 0. It is not neither decreasing, so not less than 0. That means it is static, that is it is equal to 0. So the first condition here is f dash x should be equal to 0. And the second condition, now once we are sure that f dash x is 0, we have to decide whether it is maximum or minimum. So for maximum value, f double dash x should be less than 0. Okay, I am not making a mistake here, just remember this, f double dash x. This is the second order differentiation which we studied in one of the previous tutorials. Second order differentiation of the function should be less than 0. If you have doubts, just revert back to the slide in which I showed you the maximum function. Is in that we saw that a was the maximum value and every other value was going less than a. So here also we have to take the less than sign. So if the first condition f dash x is equal to 0 is fulfilled, then if f double dash x is less than 0, the function will be maximum, and if f double dash x is more than 0, the function will be minimum. So this is how it goes. So first we have to solve this one, and then we have to check whether one of these two should be applicable. So whichever is one at that point, the function will be maximum or minimum. Let us take it out step by step. Let us understand what are the steps to calculating these sums. First of all, we have to find the first order derivative, that is the f dash x for the given function. Then we have to assume that f dash x, that is dy upon dx, is 0. Putting is equal to 0, we have to solve the equation and we will get two values of x. Okay, this is something like factorization. So these two values of x give us the stationary points. It can be maximum, it can be minimum. Now to check it out, we will find out second order derivative using the first order derivative, and then from the second order derivative we will put both the values of x which we have got from the first second step, and check whether it is more than 0 or less than 0. If in the second order derivative a particular value of x gives us negative answer, then it is less than 0, so the value will be maximum. If the second order derivative gives us the positive answer, that means it is more than 0, then it is the minimum value of the function. So let me repeat once again, if the second order derivative is more than 0, then it is minimum. If second order derivative is less than 0, that is it is negative, then it is maximum. So the value which gives us the maximum answer will be put into the original equation to get the maximum function, and the value which gives us the minimum answer will be put into the equation to get us the minimum value. I will take one example so that you can understand it a lot better. We will start with an illustration, that is illustration 25. First, we will take fx is equal to 2x cube plus 3x square minus 12x minus 4. Now, this is the question given in the illustration. What we are going to do is find the first order derivative, that is f dash x. So, 3 2s are 6x and then square, 3 2s are 6x, just x will become 1, so just 12, and minus 4 will be 0. So, we are not writing it down. So, this is the first order derivative. Next, we are going to assume that first order derivative is 0. Okay, so that is 6x square plus 6x minus 12 is 0. But I will take 6 common from all of these values to make it simple. So it will be just x square plus x minus 2. So 6 divided by 6 is 1, 6 divided by 6 is 1, 12 divided by 6 is 2. Now x square plus x minus 2 will be factorized. So for that I will split the middle term into 2x minus x. So x will be converted into 2x minus x. So x square plus 2x minus x minus 2. Now from the first part, I will get x common. So it will be x plus 2, and from the second part, it will be just negative 1. Okay, so my factors here will be x minus 1 and x plus 2. So it is x minus 1 is equal to 0 or x plus 2 is equal to 0. That is, x could be 1 or x could be negative 2. Okay, so these are the two values available for me. Next step will be to get the second order differentiation. Okay, so finding second order differentiation, f double dash x, this equation here will be differentiated. So 6 2s are 12x, then 6x will be just 6 and negative 12 will be 0, so it is not written here. So f double dash x is 12x plus 6. Now we have two values of x available here, x is 1 or x is negative 2. So first we will take x as 1 and put it into the equation of second order differentiation. So f double dash 1 is 12 into 1 plus 6 is 12 plus 6 is equal to 18, which is greater than 0. So according to our rule, when second order differentiation is greater than 0, the function will be minimum. Okay, so when I take x is equal to 1, my function will be minimum. Okay, next I will take x is equal to -2 and put it into my equation here. So 12 into -2 plus 6, 12 negative 2s are -24 plus 6 is -18. Now this is less than 0. Okay, so function will be maximum. So according to my sufficient condition, when second order differentiation is less than 0, the function will be maximum. Next, now I will be putting x is equal to 1 to get a minimum answer and x is equal to -2 to get the maximum answer. So taking f1 for minimum value. Okay, so in my original equation here, okay, what I have written is f1, that is my original equation. I will be taking 1. So 2 into 1 cube plus 3 into 1 square minus 12 into 1 minus 4. So 1 cube is just 1, 1 square is just 1. So I will be writing it 2 plus 3 minus 12 minus 4. So answer here is -11. That is the minimum value of function will be -11. Okay. So are you getting the point here that when we take x as 1, the function will get the minimum value. And now when we take x is equal to -2, that is f is -2, we will get the maximum value. So I will put it once again in the function here, -2 cube and then -2 square and then into -2. First of all, -2 cube will be -8, -2 square is 4, 12 into -2 and minus minus makes it plus 24. Okay, -8 2s are -16, 3 4s are 12 plus 24 minus 4. When we simplify it, I get 16. So the maximum value of function will be 16. Okay, so this is how we calculate sum, where we have to find the maximum and the minimum values of the function. Okay, quickly I will just recap what we did. First of all, we got the question here, then we got the first order differentiation, we assumed it as 0, factorized it and got two values of x. Then we found the second order differentiation, put both the values of x into the second order differentiation and found again two answers. Now if the answer was positive, it will be minimum. If the answer is negative, it will be maximum. So x is equal to 1 will give us the minimum answer and x is equal to -2 will get us the maximum answer. So this x is equal to 1 will be put into the original equation to get the minimum function, and then x is equal to -2 will be put in our original equation to get the maximum function. So this is how the biggest sum, one of the biggest sums of this chapter is solved. In the next tutorial, I will be discussing some more of these sums and then the next concept. Till then, see you next time.